Hello, welcome back to another Godot tutorial. In this tutorial, I'll show you the code and the reasoning for how to do a swing-like movement using a kinematic body. As you can see with the swing-like movement, you'll be able to swing from a point A onto another point, jump off, and carry your momentum. Though that last carry momentum part is modifiable, and as well, you'll be able to hit other obstacles if you're low enough down on the swing. Like this. And now for the coding part. My character controller currently uses a state machine. In the state machine, we see that we have three different functions. We have a floor detection, we have a falling, and we have a movement. The falling and the regular movement are based on whether or not the player is on the floor. If they are not on the floor, then it goes for the falling movement. If they are, then it goes for the regular. Which means that a swing is just a state of movement. The swing-like movement pulls from the abstract movement, and this is how I implemented a state machine. I had an abstract movement, and I pulled from that in order to be able to change very specific things on how I wanted to move. Now, getting into the swinging part, we have an anchor point, a right vector, the previous dot, the speed, the max swing angle, and the max distance. The anchor point is just the point in the world in which we'll be swinging around. The right is for the purposes of my project for swinging only in two different directions, forward and backwards, in relation to the swing. We then have the previous dot, which is a dot product that we got previously on the first frame. We then have the speed, how fast we want to be on the swing when we're moving. We then have the max swing angle, which isn't necessarily an angle so much as it is the max dot product available to us. And then the max swing distance, which is so that way we don't slide down the rope. Because one oddity that I had found is that without a max distance, you slowly descend the rope. Not very quickly, mind you, but you do kind of pull away from it. This could probably be implemented so that way you have a min and max distance, and you increase your minimum and your maximum distance both at the same time. So that way you can control where you are on the swing, or on the rope, really. We have the constructor for the swing class, which takes the anchor point and which takes the right. Both of these are assigned up here onto their variable. We then have the speed, which is also something you can modify. I used two different floats. I used the gravity and the total speed of the player at that point in time. We then want to get the forward direction, so that way we can use it for determining which side the player is on for the rope. We get the end point, or rather the direction to the anchor, which is simply the anchor point minus the player's current position in the world. We use the endpoint. We get rid of its y-axis, so that way we can get which side the player will be on more easily. If this, because this one will be parallel with the ground, we also want to make our direction parallel with the ground. We then have to normalize it, because when using a dot product, it most typically expects two normalized vectors. Without a normalized vectors, your results are a little bit weird and squampus. We then take the right angle, we multiply it by either a 1 or a -1, and that's determined by whether or not the endpoint is facing the same direction or the opposite direction. The same direction will be a 1 because it'll be greater than 0, but the opposite direction, or something less than 0, will output a -1. This could be put into an if statement, but I prefer the shorter version of an if, because it's only assignment. We then get the max swing angle, which is clamped to 1 and -0.8, because a -1 will be right above the anchor point, and I'd rather not have that type of behavior. Then what we do is we take 1 minus the speed divided by 10. Now, this little part is still being worked on, and there's still some oddities that are being produced with it that need to be worked out. But that's in due time. Finally, what we do is we get the distance from the player to the anchor to set our max distance. Now, if you remember before, the falling movement and movement were both two standard functions in our state machine. I have overwritten both of them to allow for both of them to handle swinging as if you were always in the air, even if you aren't. Finally, with the swing function, what we have is we have the dot product of the up and the direction to, normalized. What this is if the player is directly underneath the anchor, the dot product will be parallel with the up vector, meaning we get a 1. However, after it passes a perpendicular point along the swing, that dot product will then be 0, and anything past that perpendicular point going upwards will be a negative. So that's how we should expect our behavior to happen. We then see if the dot product is less than the max swing angle, and if it's also less than the previous dot product. Because you can end up in a state where you're past the max swing angle, but you didn't move far enough down to get above the max swing angle. So that's where we checked against the previous dot product to ensure that we're actually moving in the direction that we want. If we're still below the previous dot product, then we'll flip our right angle so that way we start moving down, because the right angle determines the forward movement. We then get the forward movement, and the forward movement is the direction to the anchor, which is our up axis at this point. We then normalize it. We then get the cross product, which is essentially a right-handed rule where it says if your index finger is pointing upwards, your middle finger is pointing outwards, and your thumb is kind of making an L shape with the index finger, your index finger is the A, or direction 2. Your right is your middle finger, and the outcome is your thumb. Which means if you flip your hand so that way the middle finger is pointing in the opposite direction, you'll get the reverse of what you had before. Now what we do is we get the distance 2, and we get the length of the direction, and we make sure that it's not above our max swing angle or max distance. If it's above the max distance, we simply want to push our player towards the direction, towards the anchor, and we'll use our distance for that. You could do this in reverse as well. So that way, the move 2 goes in the opposite direction if you wish to go down the rope. Finally, what we'll do is we'll use the move and collide that Godot has with its kinematic body. Make sure to multiply it by the delta, because move and collide does not have that multiplier like move and slide does. We'll then multiply by the speed, and then we'll multiply by the dot product minus the max swing angle. What this produces is it produces kind of a slowing down effect, where when you get to your max height, you start going much slower. So for instance, if your dot product was a 1 and your max swing angle was a negative 0.8, you would get 1.8, which means you would be moving much faster at the lowest point of your swing. With move and collide, it returns a kinematic collision. Now it only returns a kinematic collision if it has hit something. So we'll check to see if it is null, and then we'll reverse the result, because if we did collide with something, then it will return something. So if it did not return null, this would return false, and then with the flip, it would return true. Knowing that we've collided with something, we can reverse the direction in which we go. Finally, we assign the dot product to the previous dot, and then we check to see if the player wants to jump. There isn't much more beyond that. With the swing, what I've done is I've set up an area to where if the player passes through it, it will see if the player is already in the swing state. If they aren't, it will assign a new swing state with the point that I've assigned through the editor and the global z-axis. Alright. If you have any further questions, let me know down in the comments. I hope this was informative. I won't be able to upload the code for this because this is a part of a larger project, and trying to pull out everything else will be a bit awkward, but if that's something you wish, I'll definitely try and do that in the future. Alright, if there's any other tutorials you want, or maybe questions you have, please let me know, and I'll be sure to make another tutorial in the future. Thank you, and have a wonderful day. Bye-bye.